Data types are foundational to programming. They allow computers to understand what kind of data they're working with, how to store them, and how to process them. For programmers, understanding data types is like understanding how different pieces in chess move. If programming is like a game of chess, then the data types are like pieces in your chessboard. In chess, you have the bishop that moves diagonally, you have the rook that moves straight, and then you have the knight that moves in an L shape. And you have to understand how these pieces move in order to play a game of chess. And so likewise with programming, if you want to program, you have to understand how the different data types work. When you've been playing chess for a long time, you'll start to realize that different pieces have different advantages and disadvantages. And depending on the situation, one piece may be more important or more valuable than another piece. And so likewise with programming, when you've been programming for a long time, and once you really understand data types, then you'll start to realize that depending on the situation, depending on what you're trying to implement, some data types will be better used for that data than other data types. So in this video, I'm going to be explaining in depth what data types are, why they matter, and I'm going to do a demo at the end with 2 programs on how to use data types. So let's get started. So my name's Henrik and I'm here to help you learn the foundations of software development. So let's get started. But before we begin, I'd like to mention that I do have a free workshop for you. It's called my Capstone project workshop. And in that workshop, I go over 3 secrets to coding your own Capstone project in just 3 months. And if you don't know what a Capstone project is, it's just a personal coding project where you apply all your newly acquired coding skills into one personal project. Now, why did I create this workshop? The most common goal that I get from people who apply to my one-on-one programming mentorship program is to, quote, be more proficient at creating projects. You and I both know that learning how to code is more than just memorizing code syntax. It's about applying your coding skills to real-world projects that make you feel confident and capable. A lot of new programmers tell me they struggle with turning what they've learned into something practical, and many feel overwhelmed trying to go beyond tutorials to build their own thing. So if this sounds like you can download this workshop in the link in the description, and if you download it and watch it and pay attention to what it says, then you'll definitely build a good foundation to your software development journey. Alright, so now what are data types? So like I mentioned already, data types are just a way for you to tell your computer how to handle different data and different information. And here's a secret for you. Computers don't actually understand the data that they're working with. To computers, it's just ones and zeros. But when you code in a programming language, that programming language also tells the computer how to process a certain data type. And so it's kind of like in the game of chess, with that analogy that I mentioned, it's kind of like learning how the different pieces move, but you don't understand why the pieces move that way. And that's how it is from the perspective of a computer. The computer doesn't know why these data types are behaving in these different ways. For example, with an integer, the computer doesn't know why the integer can only be a whole number. Only we as the programmer and only the users know why that data type is the way it is. So say for example, you want to code a program that involves money. If you code that program, the computer is not going to know what money is, although you can make it look like it knows what money is, but it's not really going to know what money is. It has no concept of money. It doesn't know why you want to use money, but all it knows is that you like to put a $sign right before the numbers before you display it, and it always has 2 decimal points. That's all it knows. And so it's the user who assigns meaning to the data and the programmer who also assigns meaning to the data. It's the humans who are interacting with the program that actually assign meaning and value to the data that's in the program. Your computer doesn't even know what the difference is between different characters. So for all these characters here in this column, if you were going to put them in your program, the computer is just going to store these binary in its memory. So if you want to store an A in your program, the computer is just going to store this in binary in its memory. The main idea that I'm getting at here is that the difference between this @ symbol and this A to the computer is just that there's just this 1 bit difference, and then how it's being displayed in the computer screen. That's the only difference between these 2 characters. So like I mentioned earlier, when you store data in your computer, the computer is just going to store them as ones and zeros. Alright, so now why do data types matter? The main reason is because you're going to have different kinds of information that you want to store in your program or in your computer. For example, you want to have a letter or a word or a phrase or some numbers stored in your program, or different kinds of numbers like a dollar amount or the number of people or someone's name. You want to store all these kinds of information in your program. And so different data types will have different advantages for different scenarios. So you really need to be smart about what data type you choose to represent your data. And in this example, I'm going to show you 5 common data types in C. So we have the int data type, the float data type, the double data type, the char data type, and the char array data type, which is just a string data type. Now these 3 data types here are for numbers, the int, the float, and the double. And then the char and the char array, those are for words, phrases, and letters. So what's the difference between using int, float, and double in your program if they all represent numbers? So it depends on what kind of number you want to represent in your program. If it's an integer, then of course you use the int data type. And this is commonly used for numbers in your program that are countable. So for example, someone's age. This is usually said as an integer. No one really says that I'm 25.5 years old. They always say I'm 25 years old or 26 years old. And so if you want to have someone's age in your program, then you usually will use the int data type. The main difference between float and double is that double is more precise than float, but the disadvantage with double is that it takes up more memory than float, and that's because it's more precise. So if you have numbers that you really need to be precise, you need to have more decimal places to represent that number, like pi, then you want to use double for that data type. I'm going to show an example later that really shows the difference between float and double later, so stay tuned for that. All right, now with these last 2, we have the char data type. So if you have someone's initial, you can just use the char data type and just store 1 character for their initial. But if you want to store someone's name, then you need to declare an array of the char data type or a string data type, and this is how you can get someone's name stored in your program. All right, now let's run this program to see how it displays the values of these variables. So let's run that. Okay, there we go. Integer age is 25, float height is 5.9, pi is 3.14159, etc. Character is A for the initial, and then someone's name, Alice. So here you can see the common data types and how they're used. And this is one reason why I prefer that beginners learn C first over Python, because with Python allows dynamic typing. And so it doesn't really force you to stick to one data type. If you have a variable like age, you can actually change the data type while you're coding. And this can lead to bad coding practices if you're starting off learning how to code this way. And so if you're learning how to code in C, you have to pay attention to what each variable's data type is. And that's a good habit to build in the beginning when you're first starting to learn how to code. All right, so now how to use data types. So I have an example code here, and say we want to represent some money information in a program, and say we have some item here that the price of that item is $19.99, and then we have the total amount, and we want to simulate buying this item 1,000 times. And then we want to see what the total cost is of buying that item 1,000 times. So we're going to use the float data type for now, because naturally you would think you would use the float data type because $19.99, that sounds like something with a decimal. So why don't we use the float data type? But you'll see with this example, this is actually a bad data type to use. And so this is why understanding data types is important. So let's run this program and see what happens. All right, so now the total is $19,990.18. And you know that's not correct, because if you were to simulate buying this 1,000 times, if you just use your own mental math, you would know that it's actually not going to cost something with 18 cents. It's just going to cost $19,990 if you're using simple math. But why is it that the program is calculating some weird number with an 18? So I have another program here to explain this problem, and the main idea is that float, it's not very precise, and so double is actually more precise than float at representing decimal numbers. So what we're going to do here is we're going to store the same value in this float variable and this double variable, and then we're going to display these values, but we're going to make sure that there's 20 decimal places that are shown. And if you run this program, you'll see the difference between float and double. So we ran this program and we're displaying the value of the float variable, and we're showing 20 decimal places. So we have 20 numbers here. And so you can see here the float value that's actually stored. It's not actually 19.99. It's actually 19.989999717771, etc. But with the double data type, the double is more precise. So the double is going to store 19.98999999. So this one is more precise than the float. And that's because the double data type has more memory that it can use to store this $19.99. But as you can see here, this is actually not ideal either because it's not perfectly precise. So what's a better data type to use for representing money? Counterintuitively, a better data type to use for representing money in your program is actually the int. And that's because we can use an int to represent cents. And this is exactly precise. So $19.99 can be represented as 1,999 cents. And this is perfect precision here. And so we can actually just have our program store money in cents, but when it's displayed, it's going to display it as dollars and cents. So we divide the total cents by 100 to display the dollar portion, and then we have the total cents modulo 100 to show the decimal portion. So let's run this one. And so there you go. Now the total is what we would expect. And so the int data type actually counterintuitively is a better data type to use for money. And so this is why it's really important to understand data types and how to use them, because it affects how you store different kinds of information in your program. All right, so there's your brief introduction on data types. Just to summarize, data types are just a way for you to communicate with your computer what kind of data you're dealing with and how to process and store that data. Then I explained why data types matter and how to use them. And I went through an example on how to choose the right data type for representing money in your program. And if you have any other questions about data types, I'd love to see what your questions are, and I'll be sure to answer you in the comment section. Like I mentioned earlier, I have a free workshop for you, my Capstone project workshop. And in that workshop, I go over 3 secrets to coding your own Capstone project in just 3 months. So if you want to become more proficient at creating your own projects, you want to move on from these tutorials and create your own projects, then be sure to check the link in the description and watch my coding workshop today. Alright, that's it for this week's video. I hope it really helped you out. And if it did help you out, please like, share, and subscribe to the channel. If you have any other questions, feel free to let me know in the comment section, and I'll be sure to answer you there. And I'll see you in the next one. Peace.